on system engineering, recent trends and advances in IoT, sponsored by AICT, Atal in Training Learning, Atal Academy. So before we start the third technical session of this online on day first here, I would like to give a brief bio profile of our third session speakers, Dr. Punya Paltani sir. So Dr. Punya Paltani sir is an assistant professor of physics in humanities and social science discipline here. He is a life member of Indian Physics Association. He was awarded with CSIR Fellowship for Doctoral Research and Tubitak Fellowship for Postdoctoral Research by Turkish government and member of IEEE Society and Optical Society of America here. He has published over 31 journals and conferences papers, filed 3 Indian patents, and authored a book on the topic optical beam propagation in nonlinear media and all optical devices. So he has patents here. So his patents details includes extraction of one beam from a mixture of two coaxially co-propagating, mutually incoherent beam of same frequency, extraction of data bits loaded on one coherent beam mixed with the data bits loaded on another coherent beam of same frequency, and coherence division multiplexing here. His patent number is 261064. Application number is 1192 KOL 2007 here. And his second second patent is on all optical bistable, astable, multi-vibrators and all optical half adder using novel all optical switching in Mach gender interferometer. Patent number 296862. Application number 791 KOL 2007 here. Another all optical passive transistor adopting a Mach gender interferometer. Patent number 304302. Application number 1044 KOL 2008 here. So books he has published along with Sarang Medhekar on the topic optical beam propagation, nonlinear media and all optical devices on through VDM Publishing House, Germany. The ISBN number is 9783639292497 here. Along with that, his research area or research interest includes nonlinear optics, photonics, plasmonics, and photonics crystal here. With this, now I request Dr. Punya Prasanna Paltani sir to please take over this session. Sir, please.
Good afternoon, and thank you very much, Vishal sir, for such a wonderful introduction. And that means continuing to our session about the architecture of um, IoT. Okay, so we will start. I will start sharing my presentation. Okay, and this presentation is going to be a little bit in a unique format. Okay, so first I will move from the top to bottom and then again return back to some of the slides and then explain them in the better way. Okay, so it's like a introduction with the architecture, then introduction with the IoT, that means IIT, okay, Internet Information Technology, okay, and then using the operational technology, information technology, I will combine both of them, and then it forms the Internet of Things, IoT. Okay, so architecture of IoT is something which is still under process, and we cannot say that the things got stabilized yet. Okay, so it's like that means things started from 2008 and they are continuously working over it, and there are several nomenclatures and forms about the architecture, and we will select one of the, that means architecture that defines the things in the most appropriate way as of now. Okay, so still I can say that the things are under considerations and continuous research is going on. So this is not the full and the final architecture. Okay, so it's still under progress. Well, I will start with the sharing of my slides. So it's able to.
Yes, sir. Your slides are visible. Please continue.
Okay, okay, okay. Was looking at the full screen. Yes, okay. So the question is arises why the architecture is so important, and the answer is very simple. We have the uh, one sincere request from all the participants. Please keep your microphone in the mute mode. Okay, thank you. Ah. So the things start with the architecture. So why do we require a architect? Okay, what is the role of the architect?
फीडबैक करूँ
So we can start with the building materials. Okay, so
तो मैं उसमें बहुत सारे तो दिए उसमें ना आपने पूरा वो
I
स्केल डालना इस तरह का देखो स्केल
1 minute. I think
उसको जैसे कि ये डालना है सपोज यहाँ पर फर्स्ट पॉइंट 2 महीने का वहाँ पर देखा था ये सपोज यहाँ पर डालो इस
can we mute
एस
all
पी
the participants?
यूजफुल बोल के यहाँ पर ऐसे स्केल डालना
Uh,
इस
okay,
तरह का
so uh,
1 to 10 तक स्केल डालना मतलब 1 के लिए यहाँ पर 1 से लेकर के 10 तक
okay, thank you. Thanks, Vishal sir. Let's start with the building material. So, what do you understand with if I am taking, if I want to plan something, a house or a school or a office, anything. So, the things started with the common things: the bricks, cement, concrete, sand, reinforcement, steels, glass, wood, plastic, and tiles, obviously for the furnishing and other things. Okay, so the same things can be assembled in a manner so that we can have a small house, a villa, a penthouse, a hospital, a school, and even if we want, we can have the auditorium and the stadiums. Okay, but even we can prepare the palace and all other things. So the building materials are same, but what make the things different is the planning, is the architect who design, who plan the things accordingly. And okay, so what are the why we require the architecture? So any project require a careful planning. A careful planning includes okay, if I am planning a house, what will be the basic requirements of the house, how much material and the my financial status supports the, no, that means the planning, how much I have to invest, and architecture Hello. Is it okay now?
It is audible, sir. Please move on.
Okay, so okay. Thank you, thank you, thank you. And sorry for the interruption. So now I switched to the another device. Actually, I heard that some echo is coming from two devices. Okay, so let's start with the architect again. So I'm sharing the slides. Okay. Huh. So the things again started with the same thing. So the same building materials. Only we required a planning structures. So the project required a careful planning about the budget, about the resources that we have, and how we can manage them in a better way. Architect adheres to certain standards. Obviously, we have to follow certain standards. If I am planning a build multi-story building, obviously, so I have to think for the foundations, the strength of the pillar, tendile materials, and other things. Okay, so architecture planning is not only about the good ideas, they are in the most places required by the law. Obviously, there are certain government law, and recently we all are aware with the case between the Kangna Ranawat and BMC. So it's about the legal and illegal things. Okay, so that means architectural is not only about structure and the planning; it's also the in-depth knowledge about the legal aspects, also whatever you are planning. Okay, so we can do the things or not. Recently we have come around along with that several such type of cases. Okay, so you might be remember about the disclosure of the privacy issues with the Facebook and even with the Googles and other companies. Okay, so these are the legal issues whenever we are planning anything, so architect have to think over that aspects also. And the most important, strong architectural blueprint, that means minute to minute details of whatever we are planning. So it's not like that trial and error, let's have the problems and we can find the solution for it. And that means the most important thing is the foresightness. In absence of careful architecture following the design principle, which likely result in something that is difficult to scale, obviously. So it might not be possible that the foundation that we are preparing is not strong enough to support the structure, manage, adapt to organizational changes, and worst of all, troubleshoot when the things goes wrong. Obviously, that means whenever the problems arises, we have to uh, have the planning for those type of that means if I am planning a sustainable system, I have to think of that. So architect is something that who plans the things. Okay, the material and the financial aspects, even looking at the mm, strategy and that means the financial condition of the system. So we have to design the things. Okay, and obviously for the future aspects. So now from the architect, let's come to the IT. So Internet of Things is something which involves the, or we can say that the is the next generation of the information technology, where not only the devices which are using, that means internet, computers, laptop, mobiles, apart from all other devices start connecting with the systems, and they will start interacting with the systems, and they start behaving smartly. Or just for the sake of example, now we are getting the smart bulbs also. So obviously our lightning is smart, our music system is smart. I can control my speed of the fans, my security systems. Whenever anyone try to enter in my home, I get a security alert. So even my door, my fan, my tube light, okay, my music system, my television, my refrigerator, my car, everything is communicating with me. Or better to say that everything becomes so smart. Even if I want to open my refrigerator, it will ask, are you the authentic person to open the refrigerator? So that's IoT. And IT architecture, that means obviously in the last 20 years we have very good infrastructures. We have a firewall, a security arrangement for the IT related things. Okay, so about the IT architecture, the network runs the business. If the network fails, company operations can be seriously impaired. Obviously, right now we are in the work from home conditions. Okay, so that means the network is the playing, or it's the real game changer. Just as the house must be designed with the strength to withstand potential natural disasters such as seismic events, hurricane, earthquakes. Obviously, the IT systems also have to be designed in this type of looking, or considering the disasters in the network systems also. So that disasters can be network earthquakes, such as distributed denials of the system, DDoS, that's called the attack. Okay, फ्यूचर ग्रोथ रिक्वायरमेंट ऑब्वियसली नेटवर्क स्लो है चाहे 4G है लेकिन आज भी हमको 2G टाइप का ही नेटवर्क मिल रहा है सो दीज आर द प्रॉब्लम्स विच आर कमिंग बिकॉज the network future growth is not assumed properly. Network outages, even human errors, okay, security issues. The art of network architecture had gained tremendous influence in IT organizations, and I can say that obviously with past 20 years of experience over the IT technology, information technology. So we have a well established security system. So we have a very good planning in these things. So IT architectures is we can say that it's stable and sustained now. And about the IoT architectures. So now imagine everything is communicating with everything. Okay, so it's the Internet of Things. Now, not only the IT devices are communicating, your things are communicating. So, obviously, its architecture will not be as simple as the architecture of our IT systems. Or even we can say that a IT person cannot design a IoT architecture. He may have a certain knowledge that we will discuss. Okay, so IT network architectures are matured significantly over the past 2 decades and is generally well understood. The discipline of IoT network architecture is new and requires a fresh perspective. Some similarities between IT and IoT architectures do exist. Obviously, whenever we are connecting with each other, so the knowledge of the networking and other things, and obviously there will be certain protocols also which are same, but the level of that information and data communicating, the requirements of increase the requirements for the adaptability of the system as well as for the enhancement of the system. Challenges are obviously, and requirements of the IoT systems are radically different from those of the traditional IT networks because there are certain challenges that we will discuss during the architectural part also. Uh, there are not certain changes, there are challenges, there are several challenges. IoT network are often understand the that means are often under the umbrella of operational technologies. Okay, so it's not only the information technology. IoT network is under the operational technology. That means operationalization of the things, how to make the things smart or how to make the systems smart. Okay, so that means finally our objective is that means it's like a feedback system. So the uh, end level sensors and actuators are interacting with the systems, and finally, based on that, the machines and the your end level object or the things are responding or behaving. Okay, so that's the part of the operational technology, not only about the IT technology. And in the further slides, in the that means slides, we will discuss which part of the IoT architectures can come under the IT part, and what part or which layers are the form, that means which layers forms the part of operational technology or the OT part. Okay. So IT versus IoT. IoT networks are responsible for management and state of operational systems. IT networks are primarily concerned with the infrastructure that transport flow of data regardlessly of the data types. And from these two things, we can have the conclusion that IoT networks includes several challenges as compared to the IT networks. So obviously the things will not be as simple as we are imagining. If I am talking about the IoT architectures. So just for the sake of examples, obviously, and in this part, the things that I am going to explore in this lectures are the, that means in the IoT architectures, drivers behind new network architectures, comparing IoT architectures. Here I will present the two basic architectures of the IoT, and then compare them. A simplified IoT architecture. Okay, so that means whatever the IoT architectures we are using, okay, either it's 1M, 2M, or that world IoT. So we will have the something common, and the things which are common are the IT and OT part. Okay, so how we can make the things simplified. Okay, we simplify the architecture, and then the core IoT functional stack, and IoT data management and computer stack. So it's the two part of that means fourth and fifth are basically the explanation of the third part. In the third part, we divide the setups in the two parallel towers. Okay, and then we will discuss these things. Okay, so drivers behind new network architectures. So here the, that means it's start with a simple what I was saying, that IT and IoT basically they are not the same things. Okay, but they are somewhere related with the that means dependent, or we can say that related. Okay, let's have the case one. Imagine an experienced architect who can build residential house for his whole career. Experience in attractive architect, obviously he can prepare the attractive architectures. Okay, requirement to make it to be functional, livable. Okay, construction code of mandated by the government, he knows everything. So okay, I can approach to a architect, he can design, he can propose me an interior, he can give a modular kitchen to everything. Okay, so one such architect who is master enough in building the residential apartment, okay, is once approached with a new type of project. So the thing arises, or the question arises, can he take a new project or a new challenge? Because he is architect, he knows how to assemble the bricks, rods, steels, wood, and other materials to have a beautiful house. Uh, Now the thing is to construct a massive stadium, auditorium, that will be a showpiece in the city and will support a variety of the sports team. Okay, so he got a challenge to prepare or to architect or design a stadium where several type of sports can be supported, or you can have the several type of events, concert, community events, and with the sitting capacity of 60,000 plus. Okay, so obviously whenever you will ask him, can you have the idea, or can you do these things? So it's like a person who can prepare the house. You are approaching him, okay, I want to prepare a castle in 200 acres. Okay, so in our ancient systems, we have Vastu Shastra for building the houses, and Sul Shastra for building the temples and palaces. Okay, so it's something like a person who is smart enough and who knows he is very good in his job, but he is good in preparing the houses or small buildings. He cannot be good enough for taking a assignment or a new project of building a masterpiece or a very massive stadium with a capacity of 60,000 plus. Obviously, the same difference is there for the case of IT and IoT. Okay, for the case of IT, the things are building like a house, and for the IoT, it's like building a stadium. Okay, so IoT network is much like difference between the residential architecture and the stadium architecture. So obviously the label of the planning will be very high. Okay, so the foundation will not be like columns and other things. You have to select the materials. Even the government norms, the codes, okay, mandates, everything will be different. Okay, so the things that means the basic label, or that means whenever I am talking about the IoT architecture, so the first thing is the drivers behind new IoT architectures. So the first plannings, who will be the part of these systems? So obviously when each and every um, thing in the IoT Internet of Thing, the thing part is connected with the network. Okay, interacting with the network. So there will be a several type of issues. The basic issues is how much things can be supported by your network. Okay, here in the IP systems, in the IT systems, we give assign internet protocols IP address of the things. So if a person working in the networking uh, domains or a network engineer, okay, so he will be smart enough to control a network to design a network lab having 200 systems, 500 systems, or maybe 10,000 systems. But what will happen if a person got the assignment to uh, have to plan a system or to bring the in the networking 1 million nodes? Okay, and that too they do not have, maybe possible some have the IP address, some do not support the IP address. They have some different way of, or I can say that in the IT system it's very easy. Your driver stops supporting the things. Right now if you purchase a mobile, or if you have any 10 years back mobile, that mobile is not supported by our new system. Either we need to upgrade the things, we have to change the drivers, and then only your IT system support the things. But if I am working in the IoT, or I want my machine to interact or to interact with the system, so I cannot change my machine. Or a factory is going for the upgradation, cannot change the machines just because he want to make the things smarter. Okay, so in that case we have to think for the alternative things. So these are the challenges that will be covered in the first part, drivers behind new architecture. Okay, so what are the IoT drivers or the challenges that the drivers, whenever I am talking about the IoT, we have to face? First thing, obviously, the challenges with a house and the stadium. That's the matter of quantity. In a house, how many people will live? Maybe possible 10, 20, बहुत बड़ा हुआ तो 100, इससे ज़्यादा तो नहीं हो सकता. But it will never have 60,000 plus. So the same thing. First challenge in the IoT architecture is the starting from the driver's end, is the scale. The massive scale of IoT endpoints. Okay, that's the sensors, the data, the things which are generating the data. Okay, and obviously the data needs to be processed, and finally the information, and based on the information you have to instruct the changes. Okay, and executions. The massive scale of IoT endpoints is far beyond that of the typical network. Okay, so that means in a typical network, 100 system, 200, 500 systems will be there. But whenever I am talking about the IoT system, so each and every smart object is communicating with each other. As a result of it, there will be few thousands to few 100,000 devices would be connected to the system. So that increase the scale. And in that case, if I will follow the conventional IPv4 address, okay, so that space quickly got exhausted, and it will reach exhausted and unable to meet the IoT scalability requirement. So in that case, we require the scale can meet with the IPv6. Okay, so internet protocols required to be upgraded, and the new version is to be. And the network continue to use IPv4 through. Okay, obviously that means that we cannot change each and every devices. So then we used to adopt a new mechanism, network address translations. Okay. So, if you remember, I think around 10 years back, each and every passbook they have or bank have the system of giving the account number. Some account number are 4 digit account numbers, some account number were 6 digits, कुछ बैंकों के account number 8 digit, 10 digit. Now we have a standard 15-digit account number. So it's the same thing. And all the existing account number 4 digit, 8 digit, they got converted to these 15-digit account numbers. So it's the same thing. Now if I am addressing the devices, I am giving them a unique ID, so I have to switch from the existing systems which can support few hundred or thousand devices to a system which can support a millions of devices. So obviously, scale. Second, a more serious concern arises with the security. IoT devices, especially those of the wireless sensors network, okay, are often physically exposed to the world. Okay, security. Shift. I don't try to see my face. Yes. Ah. Security is required at each level of the IoT network. Every IoT endpoint node on the security must be part of overall security strategy and must support a device level authentication and link encryptions. Okay, so whenever we start our WhatsApp and start chatting or video calls, they say that it's end to end encrypted, the information. So obviously, whatever I am communicating, whatever data I am giving, so these data and the communication or information need to be secure. Otherwise, if they are went to the hands of some antisocial or non-social elements, so they can create a potential threat to the system. And imagine if each and every things, or we can say that the devices are connected with the internet and it got hacked. So your AC, your refrigerator, your lighting system, everything is within the control of the third party. That's create a very difficult issue. Okay. It must also be easy to deploy with some type of zero touch deployment model. Next challenges are obviously two, and third one is the device and network constraint by the power, CPU, memory, and the link speed. Obviously, we have the massive scales of the devices which are connected, or we call them the endpoint devices. And these all endpoint devices are not designed with their memory, okay, their power consumption, and speed, data speed, and obviously the bandwidth. Okay, due to the massive scale and the long distance, the network are often constant, lossy, capable of supporting only minimum data rates. Okay, so maybe possible some devices are old enough, so like your 2G mobile, okay, or 1G mobile, so it cannot support a video call. So in that way, we have to uh, think of a network that can support a wide variety of the things. So new last mile wireless technologies are needed to support constant IoT devices over long distance. Okay, the network is also constant, meaning modification need to be do traditional network transport mechan to traditional network transport mechanism. Third, a bigger problem when we have millions of the devices connected to the system and they are generating a data because they are not smart enough. Either must have a system that make the devices smart. Obviously, we will discuss the edge, fog, and cloud. So in that way, we have but obviously this will be a problem because in the IT system, whatever is if you place a surveillance camera, its object is to record the things. Okay, so recording is going on and a GB of data is flowing through the network and reaching to the server, our CPU. Okay, so the sensor generate a massive amount of data on daily basis, causing network bottleneck and slow analytics in the cloud. Okay, new data analytics capabilities need to be distributed throughout the IoT network. Okay, so that's the solution. We create that means we do not have the centralized processing unit, or that means the cloud which can do everything. Otherwise, each and every node or the endpoint object is directly communicating with the cloud, and cloud is something which is placed several kilometers away from the that means it's the centralized system, so obviously maybe placed somewhere in the maybe away from the geographical region, several kilometers or a few miles to several kilometers away from the system. Okay, so that means sending each and everything to the cloud and again getting, so it will not be time wise economically and data wise in a many ways. So we can have a system from where the edge to the cloud. Okay, so we have the filtration at the edge, then we create the fog systems, and then we have the cloud computing systems. So that means dividing the um, several or we can say that we started making the devices smarter. So let's have not only the memory, that means it will not only store the data, it will little bit process the data such that, or let's place some sensors and a system that will analyze the data at its own level and then send the data to the secondary level. Okay, so that means it's the primary filtering, secondary filtering, and the data which is filtered at the secondary level will only go to the cloud. Okay, support for the legacy devices. Obviously, the IoT technology is a new technology, but our devices which are already there in our home, in our systems, or even just like I want to make my factory and existing architecture, okay, smart. So I cannot change the machines and everything. Okay, so the things I can place some sensors, I can have some smart devices that can add on to the system. And if my devices are already somewhere somehow digitally enabled, so we have to think about the systems by which these devices can communicate to the system. Okay, so IoT network often comprises a collection of modern IP capable endpoints as well as
non-IP devices that rely on serial or proprietary protocols. So we can have new wireless devices, or in other way, or in simple terms, I can say that if I am planning a IoT architecture, I have to think within for a system that will support a modern 4G or 5G mobile phones, as well as the devices, okay, which were somewhere somehow using these uh, 1G or 2G technologies. Okay, your conventional where the SMS systems were enough for our communications. Okay, a few kilobyte or too few or going beyond to few bytes per second speed. Okay, so digital transformation is a long process that may take obviously. So IoT network need to support protocol translations and or tunneling mechanism to support legacy protocols over the standard based protocols. Okay, so such as Ethernet and IP. So we have to design an architect or the system that will support the existing all protocols. So just like in case of IPv6 protocols, we have to make the things for the translation of IPv4 to IPv6 system. I cannot change that. Now I gave the example of our old passbook systems where the 4 digit or 5 digit account number were there. Okay, so I cannot say anyone, okay, your that account number has gone, or now you have to take a new account number, you have to open a new account. Okay, and just now the recently from 1st April the merger of the bank happens. So no bank have asked you to come to the bank and change your account from okay, now the SBI bank changes, or these different banks got changed. Okay, so that means we have to work on a system that will support the legacy protocols, all existing protocols over the new standard protocols. Okay, so there will be certain translations and other things we have to think. The need for the data to be analyzed in the real time. Most important thing. If I think of a device which is smart or Internet of Things, so the output or the decisions need to be in the fraction of milliseconds, or better to say microseconds. It should not be like our data is going somewhere and then we are receiving the output. So we cannot. So whereas the traditional IT network performs schedule based processing of the data, IoT data need to be analyzed and responded in the real time. Okay, so in the IT and IoT, because we are getting the data, so based on that signals we are receiving, we have to give the instructions to be followed. Okay, so analytics software need to be positions closer to the edge. Obviously, ठीक है, डाटा कम्युनिकेशन में ज़्यादा टाइम हमारा वेस्ट नहीं होना चाहिए. ठीक है, so obviously at the edges we have to decide, and should support real time streaming analytics. Okay, so it's like a surveillance camera is placed somewhere. Okay, so that surveillance camera is working from 24 into 7. So if we place a motion sensor in that, okay, so it will only record whenever any activity happens in the proximity of that camera. So that's the thing. And this decision is taken by a sensor. Yeah, and we make the things smarter, and we reduce our whole huge data. If the camera is, that means camera planted in a region, observing the region over the for the surveillance purpose. If no motion is happening in that region, the camera will not work. And that means the um, we can only send the data which is really important for the secondary level of analysis. Okay, so first analysis software and other things need to be done at the place very closer to the edge or the devices which are planted. So now we will discuss these points, whatever I mentioned here, security challenges and other things in the mm, little bit more detail. Okay, the security, obviously, if the world war will happen, so that world war do not require any weapons and other thing. Only capturing someone's cyberspace is enough for us. Okay, so that's the thing where we are training the hackers. They can do anything. They can hack your bank accounts. Okay, so previously the pickpocket incident happens where the person lose whatever is there in his wallet. Right now, he lose everything that is there in his bank account. So that's the thing. If the war is fought in the cyberspace, and when we are talking about the IoT, where everything is connected, so previously kidnapping happens. If I am driving a smart car, okay, so no one requires, or we do not require any person who can illegally encroach in my car. Okay, from the cyberspace, he can hack my car and he can take me anywhere he wants. So, kidnapping to anything, if I am working in a domain of IoT, will become just like a criminal is sitting somewhere and he can do anything. He can take whole control of your house. Okay, so it's not like illegal encroachment like of things. So from the cyberspace, if all your devices are connected with the system, so that means any type of outbreak can be possible. The frequency and impact of cyber attack in the recent years, we can see that it's dramatically increases. The IT network, the first line of defense is often the perimeter firewall. But in our case, whenever the IoT endpoints are located in the wireless sensor network, and some of them uses unlicensed spectrum and not only visible to the and are not only visible to the work to the spectrum analysis, but often physically accessible and widely distributed in the fields. Okay, so whenever I'm talking about IoT systems, so their endpoints, they will not be in a certain firewall in a certain uh, region or the proximity of certain regions. Okay, so they will be globally distributed. They are communicating, or they are not using the license spectrums. So that means uh, chances of their physical exposure and accessibility over the wide range increases, so as they can easily be targeted by the cyber criminals. So security issues are serious issues for the case of IoT drivers. For optimum security, IoT must be. Okay, so these are the do's that is required if I am planning a IoT network. Be able to identify and authenticate all entities involved in the IoT services. Okay, so obvious. Ensure that all user data shared between the endpoint device and the backend application is properly encrypted. Okay, comply with local data protection legislation so that all data is protected and stored correctly. Utilize an IoT connectivity management platform and establish rules based security policies so immediate action can be taken if anomalous behavior is detected from connected devices. Okay, so first, whenever we find any anomalous behavior, so immediate action need to be taken. Okay, take a holistic network level approach to security. So it's like cyber crime, or that means the security issues will not be in the local environment. Okay, so it will be like a global approach can be done. So we have to think, or we have to optimum for the optimum security. We have to follow. We have to plan architecture with These all possible points. Next, constant constant devices and networks. So the next point was after security was the constant device and network. Most IoT sensors are designed for a single job and they are typically small and inexpensive. Device have limited power, CPU, memory, and they transmit only with okay. Just like if I am transferring some file with the Bluetooth, there is something important. Still, millions of such devices are connected with the systems. So okay, so IoT requires a new breed of connectivity technology that meet both scale and constraint limitations. So if I am designing architecture, I have to think in that way. Okay, so these will be the constraints. So the devices that are that we are using, they may or may not have the memory. They do not have any processing unit. They are not smart enough. They transmit with maybe possible very small speed. They are not IP enabled. Okay, so we have to do about the data. That's the biggest problem. Okay, so data, we want the information. Okay, that means the process data. Data is something, whatever is generated is a data. Okay, so it's like the code in the all the binary codes. Okay, if you purchase an item, that also becomes a data. But maybe it's useless for someone, or maybe it's useful. So IoT devices generate a mountain of data. In IoT, the data is like gold. If analyzed properly, like enhance the customer experience, reduce cost, deliver new revenues, opportunities, and others. So most IoT generated data is unstructured. Okay, so the data generated by the IoT systems is not properly structured, or that means if we are getting the unstructured data, we cannot use them properly for deriving any conclusions or the output from the data. Therefore, unlike IT network, IoT systems are designed to stagger data consumption throughout the architecture. So if I filter the data at the first level, I will not generate any useless data, unstructured data. Okay, so at the things level or at the endpoint, if I generate a proper data, okay, so which is useful and informative for the system, both the filters and reduce unnecessary data going upstream and to provide the fastest possible response to the device when necessary. Next, legacy device support. We have discussed, I think in many cases so all they do not even have the IP. Okay, so we have to design the protocols for translation of the and the gateway devices. Okay, so that the system can communicate with the endpoint devices. Okay, so I can skip these things. Now come to the IoT architectures. So the first part that we have completed. So what is to be keep in mind while we are designing the architecture? So okay, based on that, in the past several years, architectural standard and framework have emerged to address the challenges of designing massive scale IoT network. Concept to support data process and the function that endpoint devices perform, and two are the best known architectures. Okay, so these two architectures or best known architectures are one M2M IoT standardized architecture. So it's one machine to machine Internet of Things standardized architecture, and the second is the IoT World Forum, IoTWF standardized architecture. Okay, so in the next part we will discuss what are the points of these architectures. So one M2M IoT standardized architecture. About the history of this, to standardize the rapidly growing field of machine to machine communication, the European Telecommunication Standard Institute, ETSI, created a M2M technical committee in 2008. The other related bodies also began to create similar M2M architectures. Okay, so ETSI created a committee for the M2M architectures in 2008. Based on those architectures, or that means taking the um, uh, ideas, other companies also started creating their M2M architecture. So it's something like a ordinary switchboard, okay, can be designed in several ways. Okay, but the problem is if your socket is supporting only a specific type of, or just for the sake of examples. Okay, we all are using the example. So if you remember, वो पतली पिन वाला charger and the मोटी पिन वाला charger. Right now C2 type of chargers, और उसके लिए भी वो था एप्पल वाला चार्जर और नोकिया वाला चार्जर. So it's something mobile if you are using, and if you can provide a thing that will be smart enough to be um, charging any type of devices, so that will be a good achievement. अदरवाइज आपको फिर वही चार्जर ढूंढना पड़ेगा. आप जाइए एक, जस्ट बिकॉज यू फॉरगेट टू ब्रिंग अ चार्जर, यू आर sparing huge amount of time in searching for a device that is suitable to you. So similarly, the same thing happens if one company is creating one type of machine to machine architectures, and that architecture is not supported by the another type of machine, the problem arises. Okay, so the same problems comes, and to counter these type of issues, in 2012, ETSI and other 13 founding members, okay, launch. They sit together and then decide
Hello.
a one M2M as a global initiative designed to promote efficient machine-to-machine communication system and the IoT. And the goal of the I request the participants to please mute their mics. Ah, so the goal of this to create a common service layer which can be rapidly embedded in the field devices to allow communication with application servers. Framework focused on the IoT services, application, and the platforms. These includes a smart driving application, smart grid, smart city automation, e-health, and connected vehicles. Okay, so this architecture is basically planned for. The greatest challenge is dealing with the heterogeneity of the devices, software, and the access method. Okay, so obviously, whenever we are working in an IoT system, we do not know which type of devices we may face or we may come to employ in our system, and obviously, the software is supported by the system, or the network accessing method is supported by that system or not. So, obviously, it will always be a challenge. So, the one architecture. So here, what is the actual architecture is? So the one M2 one architecture is divided in three layers. First and the foremost layer is known as the application layer. Second layer, which is shown here with the horizontal, is the service layer, and the third one is the network layer. While this architecture may seem simple, okay, and somewhat generic at the first glance, this is very rich and promotes interoperability through IT-friendly APIs and support a wide range of IoT technologies. Okay, so Obviously I can discuss these things in the next. So the first, application layer. This domain includes the application layer protocols and attempts to standardize northbound API definitions for interaction with the business intelligence systems. Applications tend to industry specified and have their own set of data models, and thus they are shown with the vertical entities. Okay, so the things are, or just to explain these things, let I want to assemble, okay, my HVAC system. Okay, so it's a smart AC system and with the house management system. So maybe possible my house management system applications are designed by some company X, and my HVAC is designed by some another company Y. And how the H and Y applications or their systems can interact with each other. So first application layer is the uh, application. One is your AC systems, and the second one is your house management system. So these two systems are two different entities, so that's why we define them in the vertical end. Okay, so if you go here you can see these automotive application, home application, energy application, they are different applications, so it's shown by the vertical. Okay, now we require the second layer or the second layer, which is service layer. This layer is shown as the horizontal framework across the vertical industry applications. Application layer part 1. Okay. Here at this layer, horizontal modules includes the physical network that the IoT applications run on. Okay, and underlying the management protocols and the hardware. So we have to create in this layer the management protocols and the hardware that will run across these various vertical application layer. The third one is your network layer. Okay, so it's your system. Now your different systems or the your applications are that means are communicating with each other. So we require the third layer, which is the network layer. This is the communication domain for the IoT devices at the endpoint. So first our IoT system is created here with the application and the service layer, and now our IoT system is communicating with the endpoints, which are nothing but the sensors. It includes the devices themselves and the communication network that links them. And the communication infrastructures, wireless mesh technology, wireless point to multiple point systems, and some of the systems, because based on the devices which do not support the wireless connections. So these systems may be wired connection, wired device connections also. So from this first one M21 IoT architecture. So let's move to the next, which is more standardized or more recent architecture, and that architecture is IoT WF. Okay, word for standardized architecture. So history of that, in 2014, the IoT World Forum Architecture Committee, led by Cisco, IBM, Rockwell Automations, and others, published a seven-layer architecture IoT architecture reference model. Offers a clean, obviously it's very recent as compared to the one M2M systems. Offers a clean, simplified perspective on IoT and include edge computing, data storage, and access. This is the new model, which is more dynamic, versatile, and more accepted architect. Okay, it provides a effective way of clearly visualizing IoT from a technical perspective. Each of the seven layer is broken down into a specific function, and security encompassed the entire model. Okay, So that means the various things that we have discussed about the IoT devices. Okay, so these things are well taken care in this part. So this is the architecture. So in the first part, if you remember M2M, the third layer, the network layer is connecting with the devices. Here the first layer is the physical devices and controls. So the sensors and points are connected. Or if I am talking about the Internet of Things, the thing is what forms the first layer of this IoT WF architecture. The second layer is connectivity. So that means the layer connecting your things and the devices to the processing unit. The third layer is the data analysis and transformations. Okay, so this layer is whether your IP or the network is supported. That means the device IP and addresses basically support the new network or not. So transformations, translations of data, whether this data is actually required to be sent for the computing or the centers for the um, cloud computing and other issues. So these things will be analyzed at the part number 3, edge computing. And if it crosses the edge computing, then comes the data accumulation, data abstraction, application, and collaboration and processing. So if I simplify this model, then this model basically is point number one, first layer, second layer, third layer, and then this part becomes the fourth and the final layer. So So IT, what using the reference model we have achieved through the decompose the IoT problem into smaller parts, identify different technologies at each layer and how they related to each other, defined a system in which different parts can be provided by different vendors. Okay, so that means these things will be taken care at the label number 1 to label number 3, all these things. Okay, have a process to define interface that leads to interoperability, defines a tier security model that is enforced at the transition point between the labels. So the last point that the ties the security model. If we go and check, there is nothing like the security. Okay, so where is this security? Well, we will discuss these things in the next slides, after one or two slides. Okay, where we will have more simplified model of this architecture. So the layer one defines the physical layer in the some control system, which is this layer is the house of the things, and things include the various endpoint devices, sensors that send and receive the information. Second layer is the connectivity layer of the IoT reference model. The focus is on connectivity. The most important function of this layer is reliable and timely transmission of the data. So the connectivity layer is further explained with the help of these devices. So it's the communication and the processing unit. So communicate between the layer 1 and the layer number 3. Okay, switching and the routing, reliable delivery of information across the network, translation between the protocols. So these are the responsibility of this connectivity layer function. The third layer is known as the edge computing layer. Actually, this is where the beauty of actual applicable IoT architecture comes. Okay, so the best thing, we are collecting the huge chunk of data, and what if we can filter the data at the initial level, the label which is very close to the things. Okay, so which is very close to the physical devices at this. Okay, the edge computing is the role of the layer number 3. Edge computing is often referred as the fog layer, or we call it fog computing. At this layer, the emphasis is on the data reduction computing, converting network data flow in transformation that is ready for storage and processing by higher layer. Okay, and for the basic principle is before the model, well, we can, it's not that much. So with this figure I can explain. So we are getting the data from this, and data is basically at the fog or the edge computing level. Data element analysis and transformation are done. So evaluate reform the data for processing at higher level. So whether the data is required to be sent to the next level or not is actually processed at this level. So that's like a filtering the data, reduce the traffic, okay, and access data for alerting notification and other actions. So now the layer number 4 to 7 is basically handling and processing the IoT data generated at the bottom layer. So data accumulation layer captures the data, store it so it can be usable by the applications when necessary. Data abstraction layer reconciles multiple data formats and ensure consistent uh, semantics from various sources, confirm that the data set is completely and consolidated data into one place, and multiple data storage, various visualization. Then comes the application layer. So these four layers basically are the part of the next processing level, or that will reach to the cloud computing part. Okay, IoT versus OT responsibilities of this IoT model. So now we have seen the 7 layers. So where the IT plays its role and where the operational technology OT plays its roles. And interesting aspects of visualizing the IoT architectures in this way is that you can start to organize the responsibilities into two labels, IT and OT lines. IoT systems have to cross several boundaries beyond just the functional layer. The bottom of the stack is generally in the domain of operational technologies, and the top of the stack is in the IT area. Okay, so if I see in this way, so we call the first 4 layers as the uh, OT part, and over that will be in the IT domain. Okay, so okay, I think yes. So these are the things where the data is real time generated. So flow of the data is very vast. Okay, and that means based on that we can at the edge computing level or the fog computing level, you can make the decision whether the data is uh, any action need to be taken by the devices or the data need to be sent for the further processing. So this all event, that means from the layer number 1 to 4, is the part of operational technologies and are completed at the real time. Okay, and the second part which is in the domain of the IT, where the QBs are based, data is at rest, and the processing is somewhere performed kilometers away at the cloud level. Okay, so the data or the information is for the future references on, and the inform that means this will not be for the real time, but based on the facts or the information processed here. Okay, the system updates this edge computing. Okay, so we have the more intelligent system which works on the outcome of these issues, whatever the reference taken from the edge computing, which is the data is communicated to the further processing layers. Okay, so a simplified IoT architectures. Now I can define these architectures in the two domains. Okay, in the more simplified manner. Okay, so first is the core IoT functional stack. Okay, or in the previous part which I was talking in the way of operational technology part, or that means whatever is working in the uh, region which is close to the thing part. And the second is the IT management and computer stack. So whenever the data is processing from this part, we required a security layer. So the thing that I was talking about, during all these 7 layers, we do not have anything like the security. So security is here. So first is the device layer, which is the things, then the communication layer, and the third one is the application layer, which forms the first stack. Okay, so I think we have discussed these things several times, so I can I skip these slides. The second, now my emphasis will be on the second part. So data management and the computer stacks. So now the sufficient amount of information is created. The information is communicated well through the network, and the application and analytics of this layer. Obviously, this required the upper layer. Okay, and the processing of this part, analytic part, either it can be done in the real time at the edge and the fog layer, okay, or the fog layer, or it can be processed in the non-real time, okay, uh, and that analytics will be done somewhere at the cloud level. So so IoT management or the computer stacks. So obviously the object why we require these things to minimize the latency. So millisecond inform that means a computer if it is work sorry system is working, then the information or the decisions need to be taken in the time of milliseconds. So each millisecond matters for many type of industrial system. Analyzing data close to the devices that collect the data can make the difference between averting disasters and cascading system failure. Okay, so if your decisions are very fast and your devices works smartly, then obviously the disasters and system failures can be promptly checked. Conversing the network bandwidth, obviously uh, we have a limited bandwidth. Obviously if uh, it's not practical to transport vast amount of data from hundred to thousands of the edge device to the cloud, nor it is necessary because many critical analysis do not require cloud scale processing and the storage. So, just like if we take a simple example, if I plant a surveillance camera and if I install a motion sensor with that surveillance camera, which click it on and off, okay, so huge amount of data can be saved with this. And the function of the motion sensor, whenever you find any motion or any change in the environment, then only that camera will start. Otherwise, it will remain closed. So this will save your power. This will save your memory. And if this memory is unit or the processing unit is placed somewhere, maybe at the center or the data center, so this whole thing can be reduced significantly. Fifth, increasing local efficiency. So if I am sending the data to the cloud, obviously, or that means in the entirely different geographical region. So first thing, my responsibility increases. Okay, whether the data communicated properly, and obviously a huge chunk of data is flowing through the system, and the most important thing, most of the data is not that much required or that means useful, may be possible at that instant of time. So immediately if you could have taken the remedies or actions over that data, that can be significantly useful. But right now at this instant of time, this data is not so much useful. So obviously if we make the local efficiency or the processing unit close to the devices or the things, okay, endpoints, so our system's efficiency could be significantly, or that means the efficiency of the IoT management system could be significantly increases. So the traditional IT cloud computing model, so it's IT model, not IoT model. So we have the endpoint, we have the core network, and we have the supercomputers or the data centers at the cloud and the cloud. So we are getting the cloud, we are sending each and everything to the cloud, processing is done, and whatever the um, things that means the decisions come, so we will only get the result. So our processing and everything done on the cloud. Okay, so for the uh, obviously the cloud have very good computational facilities they have, but not for that means huge amount of data that is coming from the millions of devices, or we can significantly in the first filtration we can find that this data is almost useless for us. We can filter out this data in the initial level also, so we do not need to send each and everything to the cloud which is located several kilometers away from us. That will significantly deteriorate our data resources. Okay, and bandwidth, they consume the huge bandwidth, and obviously data is money, and whenever I am communicating this thing through the network, I am paying to the network operators also for the data consumptions. Okay, so the problems with the cloud computing, whatever the bandwidth in the last mile IoT network is very limited. Obviously, we our cloud have the huge computational facility, but if I connect millions of the devices at in one go, so they cannot. Latency can be very high. Obviously, the communication, processing, and then receiving the output time. Network backhauls from the gateway can be unreliable and often depends on the 3G, LTE, or even satellite links. Backhaul links can also be expensive. Okay, the volume of data transmitted over the backhauls can be high, and much of the data may not be really interested, or useless data is flowing through the system. Okay, and the big data is getting bigger. The many devices, all devices are directly communicating, so okay. And the concept of storing and analyzing all sensors data in the cloud is impractical. So what comes next? A fog computing model, and that's the smart IoT model. Okay, IoT architecture model for the computational facility. So we have the smart objects. So we add the things with the sensors, make them smarter. Now they can coordinate, sense, control. Okay, and that thing. So we have millions of the embedded systems and the uh, sensors. Okay, and out of those several millions of the few 10,000 of the multi-service devices are actually with these systems communicating with your fog layer. Okay, fog layer is the primary decisive layer which is taking the decision. Okay, and a smart object, we also incorporate one more layer in the name of the smart object, that's called the mist layer. Okay, and next is the IPV. So this fog layer decides whether it can solve the issue here, or the information need to be sent to the center or the cloud for the further processing. So this filtering and this sensing is done at the primary. It's actually on the secondary level. Primary level is the smart objects, and few tenth of thousands of data. Now only few thousands of this information they reach to this data centers, and finally data centers and the cloud concludes that only 100 informations are useful. So we with this system, we reduce our information flow from millions to the few hundreds, and these 100 informations are basically processed on our clouds, and whatever the conclusions or that means actions are required, they are communicated to the fog layer in the non-real time. So this is our chart of showing the characteristics of the fog computing and the benefits of the fog computing. So just at the fog layer, if I am doing so, the fog layer is very close to the endpoints. Wireless communication between the fog and the IoT endpoints is possible, and use the real-time interaction with the devices. So obviously make the systems more fast and reduce the junk value to the system. And now comes the edge computing. Okay, so it's the first and foremost level. If I connect the devices with the sensors, okay, it's smart devices. So in recent year, the concept of the IoT computing has been pushed even further to the edge. Okay, and in such cases, it's now um, resides directly in the sensor and the IoT devices. So edge computing is also sometimes known as the mist computing. So cloud, fog, and the third one is the mist computing. So the cloud exists in the sky, so it's away from the devices. The fog sits near the ground, and then the mist is actually sit on the ground. So basically, your thing is directly connected with the mist computing devices or the edge computing devices. If they feel the data is significant for the further processing, that only data is sent for the fog computation, and further this fog computation data is sent for the cloud computation. Thus, the concept of the mist is to extend the fog to the farthest point possible right into the IoT endpoint device itself. So it makes the things more efficient, fast, and real time. Hierarchy of the edge, fog, and cloud. I think we have already discussed these things. So the most time sensitive data is analyzed at the edge or the fog node closest to the things generated the data. The data that can wait seconds to the minute for the action is processed along to an aggregation node for analysis and actions, and data that is less time sensitive is sent to the cloud for historical analysis, big data analysis, long term storage. Okay, so for example, each of the thousands, okay, I can. Well, so that's all about the architecture of this IoT, and these are the basically the references from where this material is collected. Okay, and that's all from my side. Now I can the session is open for the queries, and already we have exactly reached the time, so I can always take few questions or queries.
So if you have any questions here, then you can ask to the Paltani sir. So
uh,
feedback link is shared.
so any queries or any doubt about this session or any feedback?
Please unmute your voices. Those who want to speak here, just unmute and speak. Otherwise, you can type in the chat box here regarding your queries.
Sir, in the first slide, you said zero touch security management. Can you explore something, sir? You haven't explored that part.
Okay, zero touch security management. Actually, sir, whenever I'm talking about a zero touch security management, that means data is somewhere not exposed for any individuals. Okay, so that means the security of a one to end encryption is something like that.
Acha. It is
Okay, so
directly
it means
between endpoints
the
and firm.
individual is not involved anywhere. So something like that. If I am working in a system, okay, I am getting some information. I am encrypting that information. So that means I have the key of the encryption.
Yes.
Okay, sir. And if it is encrypted by itself by the system, so even
Mhm.
the person who designed that software do not know how to
How to break it.
unencrypt that things.
Yes. Yes.
So
That means
that's
end-to-end
the
encryption is.
exactly. So without
Thank
any human involvement, or that means
Mhm.
without any system involvement, and directly the machine is encrypting the system. So that
Thank you,
type of
sir.
security systems.
Thank you, sir. Thank you so much.
Okay, thank you, sir. So I think we can conclude the session here.
So any other query from the participant? Okay, so with this, I think there's no further question from the participants here. So now we thank Dr. Punya Paltani sir for giving such a informative session and sharing such a beautiful information with all of us here regarding the IoT architecture here. So thank you very much, sir, for your presentation and taking the valuable time from a busy schedule. So now as a memento, we want to present from the organizing team here as a impression here. With I now request Dr. Anurag Singh to give a memento here to the our Dean R&D, Dr. Punya Paltani sir. Sir, please.
Thank you, sir. Thank you
Proceed.
very much,
Thank
sir.
you.
You are very informative, sir.
Thank you.
Okay, thank you very much. So with this, I am going to close the first day session here. So tomorrow we will meet again at 10:30 a.m. here morning. So today we have all gathered here at 10 a.m. due to the inauguration session here. So from tomorrow onwards, we will be having a meeting or the technical session from 10:30 a.m. onwards here. So prior to that, you all are requested to join us here. Okay. So if you have any query or here, then you can reach through mail or through the WhatsApp to me here. I will try to be responsive to them as soon as possible. Okay. Thank you very much with this. So I end up this today's session. Thank you.